All right, so on the back from yesterday, the only stuff we really didn't cover, obviously comparing probabilities is just ordering like least to greatest or greatest to least, but with probability models, the only note that you would really need to write here, and I don't have my dot camera, I let Mrs. Goldring use it for today, is that all outcomes sum to 1. Right? So in a situation, if we look at all of the possible outcomes, that's 100% of the things that can happen. Right? So if you go to put together all of the possible probabilities, you will get a 1 in total. So like down here, where Rochelle doesn't have her probability shown, well, if we know that Manny's probability is 35%, Peg's probability is 25%, they together make 60, so Rochelle must have had 40% if she's the only other person. Right, so together, our probabilities sum to 1. That was the only thing we really missed from yesterday's notes. So then going to today's, what's the difference between a combination and a permutation? Can you give me like a real life example? Like, I'm going to give you 2 examples and see if you can maybe think about which one might be which. Like, just sheer guess even. Let's say Mr. Allen decides to make a council of the great. Right? Because I feel like Mr. Allen would do this since he always talks about his favorite students anyways. So he says he's going to make a council of the great, that is the dozen favorite students of his, right? Versus Mr. Beck decides to make a student council for 8th grade that will have a president, a vice president, a treasurer, a secretary, and a member at large, which is just a person who didn't want to do any of the other things, but you want to be on the council. What's the difference? What's
Mr. Allen is the one person who actually is vocal about his students.
I know, and it's kind of a joke, but at the same time, it's kind of his incentivizer of like, well, if you're not my favorite, just do better. That's what he always says, is like, well, if you're not my favorite, do better. Like, be better.
You guys never vocal.
Oh, I know, because I feel like it's kind of inappropriate. But what's the difference between the Council of the Great and the Student Council? Amar? What's that? That's completely not what I asked. Hell?
They have different names.
Okay, they have different names. Caleb?
One was chosen and one is like...
Yeah. I mean, yeah, with how I described them. That's not mathematically what we care about, but you're right. Alina?
This is just a guess, but I think Mr. Allen's the combination and Mr. Beck's.
Why are you guessing that?
Because permutation, well, I don't know permutations, but like for Mr. Beck, he has like different groups that are contained in one big group, whereas Mr. Allen, there's like just one group of students.
So Mr. Allen's Council of the Great would be like a circle, sitting in a room with 12 people making decisions, right? Like he would like let them decide everything or something like that. Mr. Beck's council has a president who's in charge, a vice president who's beneath them, a secretary to take the notes, a treasurer to keep track of, like, a student council has ranking, right? The order of who's in it matters, because who is president, who is vice president, who is, like, whatever. I am on a council right now that I'm just a member at large because I want to be, like, at the bottom, right? I don't want responsibilities. But if you're on the Council of the Great, you don't have a title. You're just in the Council of the Great. You're all great. You're great. So, combinations, order does not matter. So that might be what you want to write here. Beside, let's start with combinations. Sorry, I'm trying to figure out how to switch this camera. So you can't see it amazingly, and I'm probably going to have to pull back my how close I am. I know. You're upside down.
I can be upside down.
You're right, you can be.
You want to see it?
I'm really okay. I don't want to risk that. Sorry, there's nothing safe to be upside down from right now. That's not safe. So a combination, another way that we can remember it, is just a group, no order. It's just a group with no order. So it's just like if you are planning vacation and you're deciding what toys to take, or I guess you can say your little brother or little sister, but we know it. You're taking toys with you. And you have 9 to choose from, but you can only take 5. Right? Mom or dad said your limit is 5. Well, if I label my toys like A, B, C, D, E, F, G, H, I forget how many letters is 9. How many unique groups? How many different groups? Well, if I take lion, tiger, bear, horsey, and duck, is that different than taking duck, horsey, lion, tiger, bear? No, right? I just throw them all in my bag. So the order doesn't matter in a combination. Okay, so when I'm picking toy number 1, how many options do I have to pick? 9 of them. When I'm picking toy number 2? 8, 6, 7, 5, 3, 0, 9. Oh, sorry. What? What would I do? So 98,765?
No.
Okay. So
It's like 9 factorial. I mean, 9 minus what? Like 4 factorial?
You think you know the equation. All right, Kaylin. That was really, I don't know that I followed what you said. That's fair.
It's hard to explain, but it's easy.
There we go. Sorry, I was trying to get my camera to switch over to the wider view. Oh, and now it won't let me. There we go. So now we got our wider view, even though we can't focus very well. What's up, Brittany? Yeah, absolutely. So you said it's 9 factorial over. Am I using parentheses or no? I don't know. So if we do 9 factorial over 9 factorial, that's 1, right? That's a little dangerous. So scratch this. 9 factorial over 9 minus 5 factorial. Denominator or out here? Times 1 over 5 factorial. Yeah, what did you get as an answer? For how many groups?
That's right.
That's what concept. If you read the little help thing, once you get it wrong, that's what concept.
But why? But why? What does 9 factorial do?
It's 9 times 8 times 7 times 6 times 5 times 2.
Multiplies all the way down to 1, right? Absolutely. So, as Alina said, 9 times 8 times 7. Crap. So, if I just do 9 factorial, I have too many. I like multiply extra. This is what we call over counting. We're literally counting too many options because we don't have those. So we are over counting. What we have to do is fix our over counting. And to do that, exactly what Kaylin's saying, we're going to divide by something to fix the over counting. So what we divide by is the stuff I don't want multiplied out here. which is the rest of the factorial, 4 times 3 times 2 times 1, right? That's the part of the factorial we don't want. So we divide by that. This is the part I don't understand, though. Why an extra 5 times 4 times 3 times 2 times 1 in the denominator? I'm not disagreeing,
No, I know. I'm just.
but why?
I think what I understood is what you're multiplying by is canceling out the overcounting. What I didn't understand is why you did the 9 minus 5 factorial or divided the 9 factorial.
So let's break this apart. I'm going to grab a separate sheet of paper.
Wait,
I know, wait, right?
isn't that redundant?
Probably.
Okay.
So we said we want 9 times 8 times 7 times 6 times 5. I'm going to go ahead and calculate what that is. Guys, I'm not going to like walk around and be like, you're not doing this. But come on, you should be doing this with me. I already did this like, 15 years ago. Yeah, but have you figured out why? Or did you just like, oh yeah, there's a formula I can use. So let's figure out why. Right, like what the heck is going on here? Alina, do you want me to say you really don't and you can just leave? Like, is that the answer you actually want? Because that's not the answer you're going to get, and that's not the true answer. But if you just want to be like, how do you not do it? I'm not going to make you do it. But why do we want to understand things? I should not have to answer that to 8th graders. Why do I want to understand why when I turn my key, the car turns on? Because I want to be informed. Right? Like, so I can figure out if I turn my key and my car doesn't turn on, what the heck is going on? We want to be problem solvers, right? We want to be able to figure out how to think through the situations in the world. So the problem is if I do 9 factorial, right, in your math menu, there is factorial. So I forget the number. Aha, that would make sense because we're doing probability. That's a bit too much. 362,000, sorry. Yeah. So 9 factorial is way too much. That is actually doing 9 times 8 times 7 times 6 times 5. Sorry, my brain is getting tripped up. I can't talk and write at the same time. So we said don't do 4 times 3 times 2 times 1. So to get rid of the 4 times 3 times 2 times 1, we can just put it in the denominator. Right, if we want to not do that. Does that much make sense so far? That when choosing teddy bear number 1 or toy animal number 1, we had 9 options, then we only had 8 options, then we only had 7 options.
They likely explained this in the comic economy video, because if you do not, then if I not forget.
What is this thing? Alina, as soon as you get that taken care of, get your mask back up, please. Yeah, I agree it's a 9. It was what we indicated was the first toy chosen, right? Is he like El Presidente toy? Like he's like rank number 1, he's the top toy, he's like the favorite, he gets like a special like cowboy hat. There's a snake in my boots.
Order doesn't matter.
Okay, order doesn't matter. Order doesn't matter for combinations. Order doesn't. Okay, play with this for a minute. If order doesn't matter, I really don't think I have 15,000 different groups of toys I could take. That seems very big.
I don't know why you do factorial.
Kayla?
I think why you multiply it by 1 over how many choices you have factorial is because you're getting rid of all the doubles.
What do you mean?
You mean, like, let's say, I brought, like, my first choice was like an elephant, and my second choice was like a rhino or something.
So let's say we have an ape, a baboon, a chimpanzee. I don't know. You guys make up names.
Elephant,
Frog.
horse.
Wait, who skipped G? 1, 2, 3, 4, 5, 6. G. Iguana. Right? Whatever. So if I take my first 5 animals, is that different than that? No. And it's also not different. C, D, E, A, B. Also not different than that, right? It's also not different than if I go A, C, B, D, E. Or A, E, B, D, C. Or A, D, C, B, E. Or A, I could do this all day long. Or not quite all day long. I could do this 5 factorial long. Because the amount of rearrangements of a group of 5 is 5 factorial. If you want to understand what we're talking about more, I encourage you to go into Khan and watch the handshake problem video, and or like there's a bunch in there. By the way, as a reminder, in case we have forgotten this, because we literally just may have forgotten this, when you go into Khan, if you just click the drop down at the top, you can go into whatever course you want and look at whatever you want. So we are in the See All Math. We're down in high school, right? We're in the integrated math 2 class. So you could go all the way down to there. It shows me way too much. It'll show you less because I'm the teacher profile. But yeah, if you want to go in and look at this stuff, there are some sweet videos about it. You can also Google it. So let's imagine if when you walked in, of course non-COVID times, I said shake hands with every person in this room. Well, if I am person A, and I shake hands with person B, C, D, E, F, G, H, I, person I is not going to come back and shake hands with me again. We already shook hands. So it's like if anyone goes to church, it's like when you greet people during church, and you're like, peace be with you, or whatever. Like, I don't double back to the person that I already shook their hands with unless I'm being a goofy teenager, and then we would just keep shaking the same hands over and over again because we thought we were funny. So, this is another over counting. So guys, that is like a vocab word in a way. Like you'll see that on tests and things like that. So our formula has to compensate not only the over counting of the extra times 4 times 3 times 2 times 1, but also the extra over counting of this one option of A, B, C, D, E also encompasses every other rearrangement of these 5 letters. Does that sort of make sense? So the formula that we derive is actually the number of things in our group. What do we want to call that? Do we want to give it a variable? The number of things in our group? N. Okay, so N factorial, we said, over, if we're going to, pick things out of our group, we're going to remove things and place them, elsewhere, right? Like, if I have, a cart of books and I start removing them onto the shelf, so let's just say, R, right? R amount of items. So, we said we're going to do N factorial over N minus R factorial. But then we also said that to get rid of the rearrangements, since order doesn't matter, we also have another in the denominator r factorial. So if we want to clean this up a tiny bit, we can actually move that r factorial to the front, or we just don't need a multiplication symbol. But we can say n factorial over r factorial times n minus r factorial. This is our combinations formula. We'll get there. We'll get there. Hold on. So if we go back to when I was a kid, I don't know about you guys, but I had favorites, right? This toy is better than that toy, and like my bike is better than my skateboard, but like I would rank things. Part of this is like me just trying to teach a lesson, but part of this, sure, I'd see Alina throwing judgmental eyes at me. So if we're going to rank things, or if, let's say, Mr. Beck is making a student council now, and order does matter, what part of this formula don't we need to do? The r factorial in the denominator. So if we then turn this into a permutation where order matters, we still need to get rid of overcounting that we don't need, but now we just have n factorial over n minus r factorial because we do not divide out to compensate. So guys, what if I'm removing 9 things? So like, what if I have 9 toys and I'm taking all of them? Well, how many ways can I take all of my 9 toys? 1, but if I say that order matters, how many different ways can I order 9 toys? That's a different question. Katie Ann? So, R is the amount of things we're going to remove and like make a group. So, if I have 9 toys, I'm going to remove 5 and take them with me. Right? R is the amount that I pick. So, if we come over here to we get a free ticket to a boat ride, and we get 4 extra tickets. Like 4 friends can come with us. I'm rolling deep in friends. I got 6 friends. Right? I got half a dozen friends. Whew! Brush that off. So I'm going to say, all right, I, on my first choice, could pick 6, 5, 4, 3, 2. Wait, no, I only have 4 spots. No 2. Right, so my first spot, I have 6 friends to choose from, 5 friends to choose from, 4 friends to choose from, 3 friends to choose from. But since we're all just going to ride a boat together, order doesn't matter, right? So if I write out the work, and I'm hoping this helps make more sense when we actually write out the work, notice I didn't do 6 factorial on top here. So if I go to write out the work, the only thing I would actually have to divide by here is the fact that the amount of rearrangements of 4 people is 4 factorial. However, if I want to use my factorial on top, and I do 6 factorial, we also have to get rid of the extra times 2 times 1. Which that is what this 6 minus 4 factorial, that's going to be 2 times 1. So if I just write out the work and think it out, but a lot of times, guys, there's a bunch of numbers to deal with here. Sorry, and this is 4 times 3, not 4.3. Sorry, that dot's kind of low. Let's compare some other situations, right? So if we drop down to the let's try a slightly different problem. So Mr. Beck decides he's going to make that student council. Of your 8th grade class, apparently a lot of you are apathetic and you're like, nah, whatever, student council, who cares? 7 of you decide, yeah, I would go for student council. So 7 of you run, right? And you're like, I want a position. And there are 4 positions. No, there are not 4 positions. There are president, treasurer, and secretary. There are 3 positions. So, does order matter here? Yeah, because there are positions, there are rankings. So when I go to fill the spot of president, and I'm actually going to do my work up here. When I go to fill the spot of president, how many options are there? 7. Assuming I fill president first, there are 7 options. When I go to fill treasurer, how many are there? 6 now. And when I go to choose secretary, there are 5 now. Because if we're just doing the math, it's not that difficult to think through how many options, how many options, how many options. This is it. This is the answer. You don't need to overly complicate it. However, and this is why I didn't want you to look at the formulas first, if we want to utilize a formula, we can. It just almost makes it a bit more complicated because the formula that we would use here would be 7 factorial for I have 7 candidates, but then we're going to choose 3 spots. So I do 7 minus the 3 spots that we're choosing. And what that does is it takes my 7 factorial and puts it over 4 factorial. So that the math that ends up happening is just 7 times 6 times 5. Like, this is why I didn't want you guys just jumping in with formulas, is because we want to think about why is it what it is. Because my first spot has 7, my second spot has 6, and my third spot has 5 people available to fill it. When order matters, that's it. There's nothing else to compensate for. There's no over counting. So think about that for our license plate situation there. Ooh, no letter is used more than once. By the way, guys, this second license plate problem down there, what I meant to say is any letter or number. So these are 2 different problems. Where this is just asking about not using the letters more than once, making unique license plates. But down here, any letter, any number, any space. Right? That's why I have a license plate over there, is to talk about how many different combinations are there. So notice that license plate doesn't start with letters. Right? That starts with numbers. A plate can be letters or numbers or whatever. In your graphing calculator, which, sorry if I didn't get to you to get you one, I meant to grab it out of the cabinet so we can go grab some out of the cabinet if we need. It's unlocked right now. To find factorial, always go to math menu and then go over to probability. Always go to math menu and then go over to probability. Factorial's down there. But wait! What do we also see in that menu? NPR, National Public Radio. No, that's our permutation, guys. And NCR, that's our combination. If we have a graphing calculator for us, it will do everything for us. So if we go back up to the top, to our 9, choose 5. Guys, watch me if you want to see how the calculator can do it for you. When I hit NCR, it's going to open up boxes for the beginning, or like the subscript in front and the subscript in back. There's code in the calculator that is now going to do this work for us. All we have to do is tell us we started with 9 options and we're choosing 5 of them. We started with 9. This is 9C5. Sorry, I can't, with this camera, if I get closer, you just really can't see it. Sorry, it won't focus because it's a webcam, not a dot cam. Sorry, I let Mrs. Golder use my dot cam today. So 9C5, we really get 126 from that first situation with Luis. So if I go to look at Ashley packing her Fabergé eggs, because, you know, we all travel with our Fabergé eggs. I go math. I go over to probability. I do NCR because it's a combination. And I tell it 8, choose 5. Ashley has 56 ways in which she can choose what eggs to take. As Ashley takes more eggs, like if I change this to choose 6 eggs, do you think that the choices go up or go down? Of the ways, the amount of groups that can be made. Well, let's try it. Second entry. If I change my 5 to a 6, I have 8 eggs. Now I'm going to take 6 of them with me. Well, there's actually less groups because I'm taking more with me. There's less difference in groups because, guys, if I take all of my eggs with me, how many different groups can I make? Just 1. I took them all. If I only leave 1 egg behind, 8, choose 7, there are 8 groups because I can only leave 1 egg behind in 8 different ways. Are combinations making sense / what questions do you have?
The little dotted box, I might be missing something, but for some reason that doesn't make as much sense to me as the other one.
The students in class? Yeah, so if the teacher picks a group of 3 at random from 10 people, what's the probability that everyone in the group is a girl? So this is one of these interesting situations where the formula may not just straight work out for us. It might, but like it might not. So let's think this through. Choice 1. Person 1. Teacher picks a group of 3 at random. How many options do I have to satisfy what I want? Close. Give me 5 minutes and they'll be out of here at 11:30. If I want every person to be a girl, we have 4 choices that would satisfy what I want, right? It's always about satisfying what we want. So, okay, 4 options to pick. And then 3 options left, and then 2 options left. Can you give me till 11:30? Because then they'll be done with class. Interesting. So we wouldn't want to do the ×1, but that wouldn't change anything. How many total group choices would there be? So just when I go to make the group, how many people could be chosen first? Not to satisfy what we want, but just in general, the group. 10. What's up, dude? I cannot hear you at all. You got to step in here at least. Probably, but it depends what you got nothing with you. So what's up? What do you need? I might have it for you. Yeah, come back in 5 minutes. 10 times, well, my second person, I would actually have 9 options. And my third person, I would actually have 8 options. Sorry, brain fart, right in the wrong thing. Interesting. Now, does order of this group matter? crap, order doesn't matter, right? If I have girl, 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 it doesn't matter if I switch them around. So crap, I still have to compensate for that overcounting of... How did we say we fixed the overcounting? What would I divide by? The number of spots factorial, right? To fix the overcounting for order, it's the number of spots factorial. So here, still, this would have to divide by 3 factorial, right? For number of spots factorial. If we manually do this, the amount of groups that could be chosen, 10 times 9 times 8, but divided by, well, 3 factorial is really 6, right? 3 times 2 times 1. So there's 120 possible groups of kids. 4 times 3 times 2 divided by the 6. 4 groups of girls. Of all girls, right? Oh yeah, because girl A, B, C, girl B, C, D, girl C, or girls C, D, A, and then there's one more group. I would need to write it down to think about it. So there are 4 groups of just girls, 120 groups total. What would I do now? The girls out of all of the groups, right? So 4 out of 120. At this point, flip your paper. Stop it! No, I'm just joking. So, your formulas are back here. Your examples of a couple just the problem we just did, because I know it's ridiculously complicated. So, this problem, the 10 students in a class, 6 are boys, 4 are girls, here's how they explain it. And I wanted us to do it in a different way than what they do, because they just use the formulas. But guys, if you don't turn on your brain, this won't make sense. So this complicated jargon right here, please look up at the board. This complicated 10 factorial blah, 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 that was what we did on the front as just, come on, get back to the right camera. Sorry, technology is not agreeing with me today. That was, I'm going to just be cool about everything because it doesn't matter that nothing's working right. That was our 10 times 9 times 8. This, 10 times 9 times 8, that is this craziness right here. This, how do we pick 3 girls and when there are 4 girls? That craziness, that, drag back over, was what we did here. We just didn't write out the formulas. We didn't write out the factorials. We didn't use the exclamation points. And then, in the end, we end up with 1/30th, which is what 4 120ths reduces to. Because if you don't think and you just look at all this craziness, this is a lot, right? There's a lot going on here. Questions? Also on the back are your formulas so that you have them and so that you can see an example of a difference between the group being made with Jim and Tom being a pair or Jim and Tom winning first and second places. Jim and Tom. I'm really hoping you're not like very light. About to run out. Do the best we can. I'll get the stove and come spray these off also. Sorry, do the best we can. I'll get him to spray these down. guys, one of the harder things that we will do this year if you try to just apply the formulas. So make sure that you keep your brain turned on while you're thinking through these problems. Yep, have a great day, guys.